Problem 23, Quantum Mechanics. The question is, the energy levels for a particle of mass m in the potential V of x equal to A mod x determined in the WKB approximation root 2m integral a to b root of e minus V of x dx equal to n plus half h cross pi, where a comma b are turning points and n is equal to 0, 1, 2, 3, etc. are. So in the question, we have to find out the energy levels of a particle of mass m in the potential V of x equal to alpha mod x, and we have to determine the energy levels using the WKB approximation. Now, to solve the problem using WKB approximation, first we have to find out the turning points. We know that at a turning points, the total energy become equal to the potential energy. Here, the potential energy is alpha mod x. We have V of x equal to alpha mod x. We can write the potential as minus alpha x if x less than 0 and alpha x when x greater than or equal to 0. We can write V of x is equal to minus alpha x if x less than 0 and alpha x if x greater than or equal to 0. Now using this, we can say that the turning points E equal to V of x or E is equal to alpha mod x are x1 equal to minus E by alpha and x2 is equal to plus E by alpha. That is, we have two turning points. X1 is equal to minus E by alpha and x2 is equal to E by alpha. Now once we have the turning points, we can calculate the energy levels of the particles using WKB quantization condition. So what is the WKB quantization condition? If x1 and x2 are the turning points, then integral x1 to x2 p dx, where p is the momentum, p is the linear momentum, x1 to x2 dx px or p dx, that is equal to pi h bar into n plus half. This is the WKB quantization condition. Integral x1 to x2 p dx equal to pi h bar n plus half, where n is equal to 0, 1, 2, 3, etc. Now we can write it as integral x1 to x2. We can write the momentum p as square root of 2m into e minus v of x. Instead of p, we can use p is equal to square root of 2m into e minus v, then dx, that is equal to pi h bar into n plus half. Therefore, integral x1 to x2 square root of 2m into e minus, here in the given question, V of x is alpha mod x, the potential is alpha mod x, therefore square root of 2m into e minus alpha mod x dx, if we integrate from x1 to x2, that is equal to pi h bar into n plus half. This is our WKB quantization condition in the present problem. Let it be equation number 1. We have to simplify the equation number 1 and find out what is E. Since we have the turning points x1 is equal to minus E by alpha and x2 is equal to E by alpha, our integral becomes, or the equation 1 becomes, integral minus E1 minus E by alpha to E by alpha square root of 2m into e minus alpha mod x dx, that is equal to pi h bar into n plus half. Now let us take square root of 2me outside the integral, then it will becomes integral minus e by alpha to e by alpha. Then square root of 1 minus alpha mod x by e dx, that is equal to pi h bar into n plus half. Now this is equal to square root of 2me into, since we have the modulus function, we have to separate the integral from integral minus e by alpha to 0. Then the integral become 1 plus alpha x by e all raised to 1 by 2 dx plus integral 0 to e by alpha, then 1 minus alpha x by e all raised to half dx, that is equal to pi h bar into n plus half. This is equal to pi h bar into n plus half. Now let us evaluate the integrals. That is square root of 2me within bracket square root of 2me within bracket the value of the integral is 1 plus alpha x by e all raised to 3 by 2 into, you will get 2e by 3 alpha into 2e by 3 alpha plus, now the limit of integration is minus e by alpha to 0, then plus square root of 2me. Now we have to evaluate the second integral, that is 1 minus alpha x by e raised to 3 by 2 into minus 2e by 3 alpha. That is equal to pi h bar into n plus half. That is equal to pi h bar into n plus half. We have to apply the limit from 0 to e by alpha. That is equal to pi h bar into n plus half. Now this is equal to square root of 2me. Now let us apply the limit. We can take square root of 2me into 2e by 3 alpha outside the bracket. Now the first integral become 1 minus 0 and the second integral become minus 0 minus 1. After applying the limit, you have the answer is square root of 2me into 2e by 3 alpha 1 minus 0 minus 0 minus 1, that is equal to pi h bar into n plus half. Now this is equal to 4 by 3 e by alpha square root of 2m, then e raised to half. That is equal to pi h bar into n plus half. Now, after simplification, you will get the value of e as, after simplification, you will get the value of e as 3 alpha by 4 root 2 m, 3 alpha by 4 root 2 m, then pi h bar n plus half all raised to 2 by 3, all raised to 2 by 3. The answer is E is equal to 3 alpha by 4 root 2 m pi h bar n plus half all raised to 2 by 3. Therefore, from the given option, option B is the correct option.